The first one to speak at this section will be Sergey Markov from Sber Devices and Dimitrov from Sber AI, talking about multimodal neural networks. Over to you. Hello everyone, thank you for coming to our conference. We are pleased to have that many viewers today. We'll tell you about our ruDALLE project, which is a multimodal neural network, and probably the outcomes of its operation are known to many of you. ruDALLE is a follow-up on what we did to create neural networks based on the transformer architectures. And actually today, if we look at the main developments in the creative artificial intelligence evolution after the transformers revolution, the technology landscape looks as follows. We have models that can work with text and generate texts. These are GPT models, and that family in Russia is represented by ruGPT-3, which is our latest solution. We created it last year. And apart from that, we have the encoder-decoder architectures T5 and its Russian analog, Russian version, ruT5, created by Sber. There are models that can compute music like the transformer generative architecture, pop transformer, MuseNet, jukebox, and our models Synformer and Composer. Today we will tell you about the third line of our activities, to generate images, not only to generate them, and such transformer architectures can resolve a broad range of tasks, and that is called ruDALLE, coupled with ruCLIP model. For us, the source of inspiration was the OpenAI model. We learned about that from the very outset on the 5th of January 2021, when we saw a post in an AI blog about by the people of that group that can generate images according to a textual request and can transform images in line with the textual commands. And that post had some information, and that can be supplemented by additional thinking, and some of the details were added in an article that appeared in late February. Although it was not about ruDALLE, it was about one of the components of this model. After a while, the OpenAI repository saw a code for encoder-decoder DVAE encoder, which is one of the components of ruDALLE. What is noteworthy, the weights have never been published, the code for training has not been published, data for training the model wasn't published either. In order to create the analog of the model in a short while, we had to bundle together the major research teams of Sber Devices and Sber AI. Also, we engaged Samara University team and Sber Cloud. Thanks to their help, we have been able to tap into the Christofari computing power, which is the most powerful computing resource. And let me now hand over to Sber AI, one of the leading professionals of Sber AI, Dimitrov, who will delve into technicalities about DALLE. Hello everyone, my name is Dimitrov I'm head of the computer vision team at Sber AI in one of R&D units of Sber, and we have been doing multimodal models of late together with Sergey and his Sber devices team, and I want to tell you something, a quick word about the comparison of the original DALLE and our ruDALLE XXL, which we called Kandinsky, naming it after the well-known Russian abstraction painter. And we wanted to compare the numerical parameters, but for you to have any sense of these figures, let me tell you about the essence of the ruDALLE and DALLE models. For layman, it is a transformer, which is the most popular architectures of today that kinda can provide quality, sort of quality, and it can be used for translating from the natural language to the language of images. So you can think about it as a translator from Russian into English, but the language of images seems much more difficult than the natural language, although it is a debatable issue and question. But it seems very simple, but it is not simple actually. If we take an image or a pic, and what is that? It is a matrix. If it's black and white, it's a two-dimensional, and each of the pixels would code the intensity of the black color. If it is in color, there are three channels: red, blue, and green, and it's going to be a three-dimensional matrix. If we take the pixels as they are, probably nothing would happen. This is why autoencoder comes into play. It can take a picture and zoom it so that it can further on be decoded. Hence, we reduce the dimension of the space of the pictures, and we leave only the most relevant and necessary information. But more advanced FTN coders are used, VQGAN, VQVIA2, and others. These are variation encoders that can reduce the picture to a latent representation with smaller dimensionality, and then reconvert into the picture with minimal losses of data, of information. And the translation that DALLE has is from the natural Russian language, in our case, into the visual imaging language. So you can have a look at all the figures, at the numbers, image representation, the fourth string, 256 by 256. We reduce it to 32 to 32 tokens, visual representations in the visual dictionary that are a translation target for ruDALLE. DALLE and DALLE ruXL have the similar image representation. Where do we have this number from? We have trusted our OpenAI colleagues, and they have conducted experiments, and the factor is 8. The contraction factor is 8. It's optimal from 156 to 32. So what else matters? We have trained this encoder. We called it Sber Bakugan, and we tuned it for critical domains like images and texts, and people's faces. The classic encoders cannot restore those. And with faces, we are better performing. And the number of parameters is in our transformer is 12 billion in both versions, and the data set huge data sets are needed for big transformers. And we gathered that together with Sergei's team and the Samara University team, and we selected 120 million couples of text and picture pairs. We passed some of the sites and open English sites. You know, dataset language with DALLE is English, so there's an error in the screen, and we have both English and Russian. We translated the captions from English into Russian. We received an analog of DALLE, which is ruDALLE, that can generate pictures no worse than the original DALLE. And we also have a small-scale model of DALLE. Please visit our site and test that. And now back to Sergei. And another component of our model is the super resolution model that can generate the 225 by 225, increasing it to 1054 by 1054. This pipeline opens us a pathway to a universe of images where we could generate lots of pictures basing on their textual descriptions, and we could do the reverse, solve the reverse task also, generate a description from an image and change the pics depending on the textual queries. And we may have a tool that is relevant in very many spheres, like the interior design, where you can generate ideas, or it may be an industrial design. All those things related to new industrial prototypes, also web design, game design, and we expect a new games generation with a dynamic content where not only the textual but also graphic context will be generated on the go, on the fly, and that will help shape a gaming universe customized to an individual player. Architectural design also identical, a proprietary style development, and art projects. And it is not only about pics. Such models can become part of the immersive dynamic spaces or provide solutions for the event industry. So you can automate the creation of stock images, like automated stocks will supersede the traditional millions of pics, generating individual picture, customizing into the needs of a specific user. And Dennis will tell us more about the results. Let me continue and tell you more about the technical part. We can generate a lot of pictures on a request, on demand. OpenAI and us don't do it quite well at this point, and want to learn to range the pics in conformity with our textual description, and do that automatically because we want to get rid of manual labor. And ruCLIP, which is a model that we trained, helps us do that. It is similar to the clip from AI. It can range pictures depending on the textual requests, and it can provide the zero-shot classification of images basing on the text. The classic classification is organized like this. You have thousands of classes, more or less, and you teach the model to distinguish between those thousands categories, but the human brain wouldn't work. So our brain can not only accept thousands of labels, but any phrases in natural languages, and want to teach and train the neural network to accept millions of phrases, input phrases, and select a lot of pics and look at which phrase would correspond to what picture. Or take 1,000 pictures and one phrase and select the best matching pic. And we have trained two ruCLIP versions, the small scale with 200 million parameters and the big version with 600 million parameters, both in open access. They are open source. MS Space Hub offers the big version. ruDALLE is also open source in public access. GitHub has collected more than 600 stars in a week. That means that our model is quite popular. Thank you very much, supporters. Our XXL model with 12 billion parameters will be accessible to users in ML Space in the same data hub. Sergey, over to you. Yes, thank you. As we have said, ruDALLE required us to have 120 million image text pairs. We spent about 33 million GPU minutes to train that model. Doing that for about 2 months, 1/3 of the Christofari, which makes it the most powerful supercomputing project, the largest neural computing project in Russia, and definitely without bundling together, the two teams together, we couldn't have done that. Let's look at the samples and the results. These are what model generates with 1.3 billion parameters. With OpenAI performance, they demonstrate the best results out of 512 generations of the biggest model. You can see high quality generation outcomes because the 12 billion parameters generated 512 pics. And then the CLIP adjuster selected the best of them, and those entered the AI publication. Well, behind the scenes is how many texts were tried and tested, and how the generation results were selected. So the model with 1.3 billion parameters can generate decent results depending on the complexity. The percentage of the successful outcomes would vary. Small models would find it harder to generate pics with multiple notions, but for simple notion pics, like Vasya Loshkin's pictures and images like this, these cities, photos that model that definitely never made, but it knows something, landscapes, and something more sophisticated. A girl with a golden necklace, 2 elements are okay, an infinite generation of memes, although you cannot read texts, but some funny things, emulating the style of different painters, also dogs and catties, or a merge of a dog and a cat. And this slide shows the instances of the biggest model outcomes, and we can see it has much more sophisticated images and detailed images, and the color scheme is much richer. We have issued a demo, ruDALLE.ru. At peak period, we had 12,000 people queuing to generate a pic, and it takes only 20 seconds to generate an image. And despite that, we had long lines, 300 GPUs. We received a lot of feedback, both from abroad and here domestically. And people, with the help of our model, have been able to have many applications that we never thought of ourselves. Millions of pics are now on the internet, and actually the number of displays of ruDALLE.eu has exceeded 4 million instances. So these models today make a foundation for the new generation of virtual assistants that will be able to perform simple tasks and instructions from the users and create individual content, customized images or texts for each of you. The best generation results will be available on Salute app with a dedicated queue and with a dedicated feed, and you use that to generate. Use this app. With this, we thank you. And I would also like to thank our big team. Lots of talented people have been involved into this project. Without them, we wouldn't have been able to scale it up that greatly. And it is an awesome project, a terrific one. And I would like to invite you to our extended workshop on Friday. We will tell you 2 times more a detailed story about our work, about what we do. Just click the link you can see in the screen. Sergey and Dennis, thank you very much. We definitely have lots of questions, but definitely we cannot discuss them because of the time constraints, and we go on.